Okay, so remember that work is equal to a change in an object's energy. And now that we have actually looked at some of the different types of energy, the thing to understand is that when work is done on an object, it changes a particular kind of energy for the object. It's a wobbly board. So when work is done on an object, it changes a particular type of energy. So before we had the generic work was equal to a change in energy, and now we can be specific and say that work could be equal to a change in kinetic energy. So this would be work is equal to K final minus K initial, or work could be equal to a change in gravitational potential energy. So this would be work is equal to UG final minus UG initial, or work is equal to a change in spring energy. So this would be work is equal to US final minus US initial, okay? So you cannot have it be where like work is equal to K final minus UG initial. Like that's not a thing, okay? It's a change in a particular kind of energy. So work can cause a change in the object's kinetic energy. Work can cause a change in the object's potential energy, things like that, okay? So you're going to analyze it through how one particular type of energy is changing. So for example, you could analyze an object in two different ways. I have this marker here, and right now it has only gravitational potential energy. If I were to drop it, I could look at it through two different lenses. I could say that work is causing a change in gravitational potential energy. It's going from potential energy of, I don't know, I'm just going to make up a number, 8 joules of energy to when it hits the floor, 0 joules of energy. So the work done by gravity is causing a change in gravitational potential energy of going from 8 to 0. Or I could flip that and look at it through the lens of kinetic energy. I could say that it starts off with 0 joules of kinetic energy, and when it hits the floor, it has kinetic energy. So in this case, if I looked at it through that lens, the work done by gravity is causing a change in kinetic energy, where I have 0 joules of kinetic energy to some joules of kinetic energy at the bottom. And that is actually going to kind of be in our next topic of conservation of energy, and looking at how my energy here actually becomes the energy there, because the work done by friction, or the work done by gravity is equal in both those cases. It just causes my potential energy to decrease and my kinetic energy to increase. But let's look at just kind of this first. So this says how much work must be done to stop a 1,250 kilogram car traveling at 105 kilometers an hour. So this is clearly looking at work causing a change in kinetic energy. So this would be K final minus K initial. And the thing that I have to be careful with is right now my velocity is given to me in kilometers per hour. So this is just good practice of how to convert. Your velocity is 105 kilometers per hour. So a little bit of dimensional analysis says that I've got 1 kilometer is 1,000 meters. And 1 hour is 3,600 seconds. And so this will get rid of my kilometers. This will get rid of my hours, and I'll be left with meters per second. So again, just good practice. You have to be in meters per second. When you do convert that, you end up with a velocity of 29.167 meters per second. So coming back to my problem, this is just 1/2 mv final squared minus 1/2 mv initial squared. So the v final is just 0. That whole thing is 0. I'm not going to even bother writing that down. So this is going to be work is equal to 0 minus 1/2 my mass of 1250 times my velocity of 29.167 squared. And you would calculate that out to be, you'd pause the video, you answer the question, now you calculate it, and you should get a big number, 531,684 joules. Okay, so that is looking at the work energy theorem, and actually this is kind of this idea of the work energy theorem where we have work is equal to a change in energy, but work is also equal to FD cosine theta, is going to be one of the ways in which we can actually link energy to forces. Okay, so this work energy theorem is going to be one of the few ways that we can actually link how I have a change in energy caused by a force. Okay? All right.